Welcome. Today we're going to teach you about standard form of an equation of line. Now, before we really get into this, we've got to go back and look at slope-intercept form. We always had y equal to something. We had this great shortcut where the slope was the number right in front of the x, and the y-intercept was always this number right here, because when you stick in 0, m is gone, and y equals b. It was nice. So you run into problems that look like this, and you're like, ooh, y is not by itself. We can't even use this shortcut. You can solve for y. If you solve for y, you are able to do this, and we subtract 3x, and we get 5y equals, you can write 9 minus 3x, or we'll write minus 3x plus 9, because look at this. If the x's are written first, we'll be able to get the slope right there. Divide by 5, divide by 5, divide by 5, and we get y equals negative 3/5 x plus 9/5. We have the slope right there. Slope is negative 3/5. And then we also have the intercept right there, 0, 9/5. And we can graph the line just like that. 0, 9/5, that's almost 2. And then a slope of down 3. 1, 2, 3, 1, 2, 3, 4, 5. And there's our line right there. Let's see how this next one works. We subtract 2x from both sides, subtract 2x, and we get 9y equals negative 2x plus 10. Great. Divide by 9, divide by 9, divide by 9, and we have y equals a negative 2/9 x plus 10/9. We can graph this. Oh, let's write the slope down. Slope is a negative 2/9, and the y-intercept is 0, 10/9. Good deal. And the graph looks like this. We have 0, 10/9. That's just above 1. And the slope, we're going to go down 2, 1, 2, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And we get the line looking just like that. Good, good. Now I want you to look at something here. All of these lines, well, here are the same two. I want you to look and see what is going on. See if we can do any shortcuts without having to do this every time. Now you are welcome to do this every time, and y equals mx plus b is the standard for a lot of people. Standard form is another way of doing it. It has some very nice shortcuts. So see if you can see this. The slope was negative 3/5. Instead of just looking up to this line, look all the way up here, and do you see something going on? See this guy right here? Do you see that? In that one and that one? Yeah, indeed. Is the same pattern going on here and here? Now you'll notice that this negative pops up. That's important to notice. That when we subtracted that 3x over, we put a negative on, and then we divided by that 5, and that's where that negative 3/5 came from. So if you're able to see the shortcut, the slope of this is going to be the opposite of this number, because it got subtracted over, divided by that number. And that's where you get the slope. It's cool. Here's the slope of this one, the opposite of that one, over this one. Oh, isn't that nice? Now, what's interesting, we could, if we wanted to, we could get the exact same intercept if we stick in x as 0. Notice on this one, x is 0. This guy is now gone. 3 times 0 is 0, and we have this equation. 5 times y equals 9. Divide both sides by 5, and we get 9/5. Do the same thing over here. 0. If this is gone right here, divide both sides by 9, and we get 10/9. You'll notice same exact thing. However, there is one slight advantage to slope-intercept form. If we were to instead, we got fractions here, which were okay in graphing, but not as nice as some people might want. What if we stuck in the x-intercept, stuck in y as 0? Go like that, and we get 3x equals 9. Can you see the x-intercept there? 3 times what equals 9? It is indeed 3. Right there. And on this one, if we were to stick in 0 for y to get the x-intercept, that guy's gone, and can you see that? X equals 5. So you can graph 0, 9/5, just like we did over on this other one. Or you could graph 3, 0, which is about right here, and then go down 3, 1, 2, 3, 1, 2, 3, 4, 5, 3/5, and there's our line. Now, I don't know if you can tell, but this line and this line are exactly the same thing. We just started on that point right there instead of the point up here, the x-intercept, y-intercept. See the next one. If we were to graph, instead of 0, 10/9, if we graph 5, 0, and then had negative 2/9, I'm going to run off the screen. I think I'll go up 2, and then backwards 9. 4, 5, 6, 7, 8, 9. Good. Oops. And there we have it. Same line as what we had before. This right out here is 0, 5. Let's try a couple more. Okay, so here are a couple more examples. Let's recap on what the shortcut is. If you have a formula that looks like ax plus by equals c, where a, b, and c are numbers, then when you solve this for y to get it in a slope-intercept form, the slope, the number in front of x, will end up being the opposite of this number, a over b. There's our shortcut right there. So in this case, we can do the slope is the opposite of 3 over 7. And it works just like that, the opposite of 3 over 7. Can you find a good point? You can either do the x or the y-intercept, and it takes a little bit of work, but if you do the y-intercept here, that guy goes away, and we have 3x equals 9, which is x equals 3. So we have 3, 0, and down 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and voila, there's our line. Let's try this one. The slope is the opposite of 4 over, now remember this is a negative 1. So that's negative 1. Do you see how that negative and that negative cancel? And we get slope equals 4. There we have it. So the slope is 4, or 4 over 1. Oh, we need a good point. I kind of like the x-intercept a little bit better. We could do the y-intercept. I like the y-intercept where x is 0. So if we stick in 0 there, you can see this guy goes away, and we just get negative y equals 11, so y equals negative 11. So 0, negative 11 is our intercept. 0, negative 11, and then slope 1, 2, 3, 4, 1. And there's the line. Can you see how nice this is to go ahead and be able to use the standard form to try it? Here are a couple problems that you should try in your video notebook. Try these 3 problems, and when you go ahead and press pause, and when you're ready to proceed, keep going with the video. Okay, welcome back. How did you do? Hopefully you did all right on them. Let's give it a try. This one, the slope is going to be a negative 2/7 following that shortcut. And if we can look, does 2 or 7 go in? It looks like if we knock out that one, we'll have an easier equation. So if y is 0, x is 2, we have the x-intercept. So we have 2, 0, and negative 2/7 slope. 1, 2, 1, 2, 3, 4, 5, 6, 7. And there's our line. Over here on this one, the slope is going to be the opposite of 8 over negative 3. That's a positive 8/3 slope. And we got to get at least 1 point still. 8 into 12 doesn't look so good. I'd like to get rid of the 8, so I'm going to put a 0 in for the x, and I get a nice easy equation here where y has to be a negative 4. There's 0, negative 4 right there, and a positive 8/3 slope. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And there's the line. Good. And the last one here. Slope is going to be a negative this number over that number. So that's a positive 4/5 slope. And, oh, neither one of those looks like it goes into it very well. So it doesn't really matter. Let's let y equal 0, and we get x is 1/4. The x-intercept right there. So 1/4, 0, and then slope 1, 2, 3, 4, 1, 2, 3, 4, 5. And there we have the other equation. To summarize, standard form. If it's written like this, You are welcome to use this shortcut, or if you prefer, you can go ahead and solve for y. And you'll notice if you do that, you'll get y equals, and you subtract that ax over there, and then you divide by b. So you'll get that as your slope. You're welcome to get y by itself, and then just use the y-intercept all the time. There's just one thing more we've got to talk about. So we're going to do another equation, something like this, x equals 7. You guys have seen this one done before. It's out where x is always 7. Goes up and down like this. And it's straight up and down, has a little intercept right there. I wanted to draw that up here so we could look at all of these different equations and kind of collect what we've done. Notice if we get the slope, we know, and this connects up with this, that this is slanted down when we walk to the right. Other thing that happens, you can see if we extend this all the way, not just to the 2 points, but all the way along, that we are in quadrant 1, quadrant 2, and quadrant 4. This guy, however, is absolutely vertical, and it's in quadrant 1 and quadrant 2. Even if you keep extending forever, because it's just straight up and down, it'll never go over into these other quadrants. It has an x-intercept that's positive, and no y-intercept whatsoever. This guy has a positive x-intercept, it's over here on the positive side, and a positive y-intercept. We look at this one, this is slanted upward to the right, so up as we go to the right, and this is because it has a positive slope. Positive means you're going up, as opposed to this one had a negative going down to the right. So if we look at this one, it has a negative y-intercept, a positive x-intercept, and it goes in quadrant 1, not in quadrant 2 ever. There's quadrant 4 and quadrant 3. It's down there. Here are some others. This is going to be slanted down as we go to the right. It has a positive x-intercept, a positive y-intercept, and it hits quadrants 1, 2, and 4. Now it's possible that you could have one go right through the origin, kind of like that, and only get 2 quadrants, but every line, if you keep extending it, will hit 3 quadrants unless it goes right through the origin, is vertical, or is horizontal. So this one goes up to the right because you have a positive slope, and it is in quadrants 1, 4, and 3. And similar 1, 4, and 3, and goes up and to the right. Oh, x and y-intercepts is a positive x-intercept and a negative y-intercept. We can tell everything about a line by that.